Have you ever tried telecommunicating with your friends? And has it ever worked? Well, would you believe me if I told you I could show you two objects telecommunicating with each other? Here, let me show you. If I have two identical boxes and I put a red ball in one and a blue ball in the other, and close them and mix them up, can you tell me which ball is in which box? Well, you can't. So, what if I open one box and you see the red ball? Now can you tell me what's in the other one? Well, yes, it must be the blue one. In order to understand this better, we first need to know what quantum superposition is. This means that an unobserved photon exists in all states simultaneously, but when measured, it exhibits only one state. This was first tested by Albert Einstein. During his experiments on quantum systems, he used photons, which have a property called spin. He split the photons into pairs such that their spin properties became related to each other. When one of the photons was measured to be in the upspin state, the other photon was in the downspin state, even without actually measuring it. This is what we call quantum entanglement, or entangled systems, where measuring one part of the system instantaneously reveals information about the unmeasured part of the system. Let's say I return the objects into the boxes, but what happens if I move them farther apart before opening, or send it to the other side of the world? What if we send it to the moon? Well, we still know what is in both boxes while only measuring one, and regardless of distance. Well, you might be thinking, if both objects are in both places until measured, how does the second object know which box to pick when the first object is measured? Well, it's quantum entanglement, communication that is instantaneous. You might be thinking, I thought nothing could be faster than the speed of light. Well, that is our dilemma, and Einstein's too. He was frustrated with these spooky phenomena that contradicted his theory of relativity, and thus proposed that there were hidden variables, unbeknownst to scientists, that explain everything. In the 60s, a physicist named John Bell decided to test these so-called hidden variables. He outlined 3 principles about the universe and experimented around them. In the end, his results suggested that entangled systems indeed exist. However, if one insists on hidden classical variables, these results suggest that there is no freedom of choice. Rather than insisting on a classical universe, most scientists continue to explore quantum physics and entanglement. There are many applications of quantum physics ranging from quantum logic clocks, quantum key distribution, quantum computers, and entanglement-enhanced microscopes, and bird migration. We know that migrating birds follow magnetic fields, but how do they do this? One theory is that birds can see magnetic fields. When light excites 2 electrons in the bird's eye, they become entangled. The magnetic field of the Earth then alters the electron spins and thus alters the chemical properties of the molecules. As a result of the chemical reactions in their eyes, birds are able to see the magnetic field lines. It is essential that we keep researching quantum entanglement. Not only will it allow us to learn more about bird migration, but it will also allow us to have lightning-fast computers and unhackable codes. And for now, just keep doing your physics homework and don't try to telecommunicate on your tests.